Okay, let's start. So, study compounds H2SO4. Alright, so, hello. We're just gonna start with H2SO4 chapter. Let's first start with what is H2SO4. It's hydrogen sulfide, basically. So, it's also called sulfuric acid. So first you gotta learn where it's discovered, how it was discovered. So sulfuric acid was initially called oil of vitriol. Oil of vitriol. Oil of vitriol. This is because it was initially prepared by distilling. It was initially prepared by distilling green vitriol, hence the name oil of vitriol. So the reaction was 2Fe2SO4.7H2O on distillation. I don't think 2 is there actually. FeSO4.7H2O on distillation gives Fe2O3 plus SO2 plus SO3 plus 14H2O. This is the original reaction, and this is just basically this H, not F. There you go. H. This whole thing, that's supposed to be H2SO4 plus 13H2O. That's the same thing. Okay, but write this in your exam. Or you can write this too. Write this whole equation and write this. So it's 2FeSO4.7H2O on distillation gives Fe2O3 plus SO2 plus SO3 plus 14H2O. And then you can write this part, which is H2SO4 plus 13H2O. This is a super important equation. Alright, so let's find out where its occurrence is. Where is it occurred? Okay, let's make this a point. Let's make this a point of one. So this is a pointer of one. There we go. So yeah. So now that was what it's originally called. That means like this is basically the discovery, you can say. Now where it's occurred. So it occurs in both the free state, and combined state. Both free and combined state. So it's formed near sulfide beds by hydrolysis of iron pyrites. So it's formed near sulfide beds due to hydrolysis of iron pyrites. I think these 2 points are enough, and it's also combined. It's also in the combined form, as it occurs in salts and minerals and metallic sulfides. Anyways, sulfates. Yeah, so this is where it's occurred. This is where you can see H2SO4. Now, how do you prepare it? The general methods of preparation. So it occurs in both free state and combined state, and it's formed near sulfide. It occurs in minute traces in hot springs, and It is also formed near sulfide beds due to hydrolysis of iron pyrites, and it's also found in the combined states in salts and minerals, just metallic sulfates. Okay, great. The general methods of preparation. So first is by action. Okay, since everything here is pretty much the same, no, I'll write, so it's fine. By action of heat, on nitric acid and sulfur. This how it'll be. So it'll be sulfur plus 6HNO3 on heat gives 6NO2 plus 2H2O plus H2SO4. So sulfur plus 6HNO3 on heating. This is not there in your book, but it's understood. But you don't have to write it here. So S plus 6HNO3 gives 6NO2 plus 2H2O plus H2SO4. This is by action of heat on HNO3 and sulfur. Then there is by passage of chlorine. A passage of chlorine. Passage of chlorine through an aqueous solution of sulfur dioxide. This is what we get. Chlorine, right? So clearly there needs to at least be chlorine and SO2 because it's by passage of chlorine through an aqueous solution of SO2. And since it's aqueous, we just add H2O. Cl2 plus SO2 plus 2H2O. 2H2O gives 2HCl plus H2SO4. That's it. H2SO4. Okay. So by action of HNO3 and sulfur, we get sulfur plus 6HNO3 gives us 6NO2 plus 2H2O plus H2SO4. And then by passage of chlorine through an aqueous solution of SO2, we get Cl2 plus SO2 plus H2H2O gives us 2HCl plus 2H2SO, plus H2SO4. Then we have two more by dissolution. Of sulfur trioxide in water. So that'll be sulfur trioxide plus H2O giving us H2SO4. That's all. Pretty easy. This is the easiest one of them all. Then we have by hydrolysis of sulfuryl chloride. Now what's sulfuryl chloride? Sulfuryl chloride is SO2Cl2 plus H2, giving us 2H2O, giving us H2SO4 plus 2HCl. That's it. So there's totally 5 reactions you need to learn. First is the olivitriol one, 2FeSO4.7H2O. 2FeSO4.7H2O gives us Fe2O3 plus SO2 plus SO3 plus 14H2O, which is basically just H2SO4 plus 13H2O. Then we have the general methods of preparation. in that we have but we can prepare it by the action of heat on HNO3 and sulfur. So it'll be sulfur plus 6HNO3. Sulfur plus 6HNO3 gives us sulfur plus 6HNO3 gives us 6NO2 plus 2H2O plus H2SO4, and then we have the passage of chlorine through an aqueous solution of sulfur dioxide, which is Cl2 plus SO2 plus 2 plus 2H2O gives us 2HCl plus H2SO4, and then we have the dissolution of SO3 in water, which is SO3 plus H2O gives us H2SO4, and then by the hydrolysis of sulfuryl chloride, SO2Cl2 plus 2H2O gives us H2SO4 plus 2HCl. Great. Okay. Now, how do we prepare it in large quantities? How do we manufacture it in large quantities? We have this thing called the contact process. The contact process. Let's do it here. There, okay. The contact process. Now this is a really large process, really big. It has a few more equations of its own. But I can section off a few parts of the a few parts. Those parts contains subparts, like those subparts are called chambers. So each part, there are totally 4 parts, or 5 parts actually. 5 parts, and each part has a chamber, 1 or more, minimum 1. Okay, so I don't think I'm going to draw the diagram. There's no point of drawing the diagram. So let's just start. So first, in the contact process, the first step is the production of SO2. Now, the production of SO2. To produce SO2, we need to first do a few steps, and those steps can be carried out in chambers. So whenever I write chamber, I'll write C dot A. So that by C dot A I mean chamber A. So chamber A is called the blower. The blower, and it is for the passage of air or oxygen. So the blower is just for the passage of air or oxygen. It's just to push air. That's all. Then we have in production of SO2 we have chamber B. It's called sulfur or pyrite burners. Let's just write pyrite burners. There. For production of sulfur dioxide by burning sulfur or iron pyrites. Sulfur or iron pyrites. There. By burning sulfur or iron pyrites. There. So now SO2 has been produced. Okay? SO2 has been produced. Iron pyrites, the chemical formula is FeS. FeS2, okay? That's iron pyrites formula. We'll see that in detail later. So first, in the contact process, the production of SO2, which has 2 chambers, chamber A, chamber B. Chamber A is blower, which is for the passage of air or O2. And then we have chamber B, which is pyrite burners, for the production of SO2 by burning sulfur or iron pyrites. Burning sulfur is just much easier. It's an easy reaction, no time at all. Alright, so that's the production of SO2. Then we have the purification unit. This has the most chambers. Purification unit. So basically, the SO4 used to be really, really, really pure. The minimum is 98%. The minimum is 98%. Okay, just ignore this. What? Yeah, it's fine. In the purification unit, we have chamber C. Chamber C is called the dusting tower. So the first part is called the dusting tower. There's totally C, D, E, F, G, H. There's totally 6 chambers in this unit. It's for purification. So basically, we want to purify any gaseous mixture of sulfur dioxide and O2. So they might have mixed because the blower passes the air or oxygen, and the pyrite burners creates SO2. So it might. This process is also called roasting, by the way. This whole process is also called roasting, but they might not ask you that. It doesn't. It's not that important. Anyway, so then we have the dusting tower in chamber C. Well, the dusting tower is for removal of dust by downward blow of steam. Downward blow of steam. There. For removal of dust by downward blow of steam. So just to remove any dust in this mixture, then we have chamber D. It's called the cooling pipes. For cooling gases by passage through isolated pipes. So basically, there'll be... Okay, I'm gonna erase this afterwards. So basically, there'll be our chamber C. Okay, it'll be connected like this. It'll dust off everything here. It's all dusted off, and then it goes through here, and here this is called an isolated pipe. So here it cools down. The temperature goes down. So. Yeah, isolated pipes. Okay. So quick recap. There's production of SO2, where we have chamber A called the blower, chamber B the pyrite burners, and then in purification unit, it's to purify any gaseous mixture of SO2 and O2, and then we have 6 towers. This chamber C, that's called the dusting tower, chamber D called the cooling pipes, and the dusting tower is for the removal of dust by downward flow of steam, and the cooling pipes is for cooling the gases by passage through isolated pipes. Then we have chamber E. Chamber E is called the scrubbing tower. The scrubbing tower. This is for further removal of impurities and dust particles by downward spray of water. Removing impurities removing impurities and dust by downward blow of water. Blow of water. It's not blow actually, it's spray. Downward spray of water. Great. So this chamber E, scrubbing tower, which removes removing impurities and dust by spray of H2O. Then we have chamber F. Chamber F is the drying tower. the drying towers. It's for drying moist gases. So here I think all the oxygen gets removed. It's for drying moist gases. Oxygen's pretty moist. So for drying moist gases by downward spray of water. So a downward spray of concentrated. Now this is a little ironic, okay? We create H2SO4 for drying moist gases by downward spray of concentrated H2SO4. See, H2SO4 is a great drying agent. It removes all the moisture from anywhere. So that's why we use the H2SO4. But why can't we use calcium oxide? Well, because it's not really that strong, basically. H2SO4 is a very good drying agent. So there's chamber C, D, E, F, dusting tower, cooling pipe, scrubbing tower, drain tower. Everything is great. We have chamber H now, or chamber G, sorry. This is called the arsenic tower. Arsenic tower. What could arsenic do here? What could arsenic do here? So, for removing any arsenic oxide by passage of ferric hydroxide. So, arsenic oxide will create, I'm not sure how, but well, it will. So, for removal of arsenic oxide by passage of ferric hydroxide. I'll just say OH. Ferric hydroxide. Yeah. So so recap till now. This chamber C, dusting tower, chamber D, the dusting chamber C, dusting tower, chamber D, cooling pipes, chamber E, scrubbing tower, chamber F is the drying tower, chamber G is the arsenic tower, and chamber H is called the testing box. And here we finish with our purification unit. Testing box. So here we check the purity of the gas by passing light. Checking purity of gas by passage of light. There. Passage of light. Through a darkened box, of course. It's obvious. Yeah, so here we're done with the purification unit. So we've purified the air. It's amazing. It's amazing. It's beautiful. It's beautiful, pure SO2. Now, we reach to catalytic oxidation. Catalytic oxidation. There. In this we only have one tower, chamber I. Chamber I. Okay? Chamber I is called the contact tower. Recap. Chamber A, blower, chamber B, power burners, chamber C, dusting towers, chamber D, cooling pipe, chamber E, scrubbing tower, chamber F, drying tower, chamber G, arsenic tower, chamber H, testing box. Then there's the catalytic oxidation, chamber I, the contact tower. There. They might just ask you the name of it, the function. If you can remember, that's great. They probably won't ask you. I think they'll only ask you for the reactions, like the production of SO2, and maybe the arsenic purifier, maybe even the drying tower. They'll definitely ask you catalytic oxidation and the absorption of SO3 and the dilation of oleum. We'll get to what they are later in just a minute. Okay, great. So we have the contact tower. So for catalytic oxidation, of SO2 to SO3. Why do we need to do this? Why do we need to make it to SO3? Because I told you here, look at how easy the reaction is. SO3, if you just add H2O, it becomes H2SO4. So that is what we do. So for catalytic oxidation of SO2 to SO3, we need to pass we need to pass sulfur dioxide and oxygen through iron tower, through an ion tower. I'll explain this to you. Packed with vanadium pentoxide. Vanadium pentoxide initially are heated up. Okay. I'll explain this to you later, just remember this for now. That chamber I is a contact tower and is for the catalytic oxidation of SO2 to SO3 by the passage of SO2 and O2 through an iron tower packed with the catalyst vanadium pentoxide at 450 degrees Celsius. Great. Then after this we have the catalytic oxidation. Never done that. For this we have the absorption of SO3. Great. Now we have the absorption of SO3. In this we have chamber J, called the absorption tower. Alright. So for absorption of sulfur trioxide vapors by descending stream of concentrated H2SO4 98%. Okay, so to absorb the sulfur trioxide, we need to pass vapors by descending stream of concentrated H2SO4. We need to pass descending vapors of by descending. No, not vapors actually. It's not vapors. Vapors is wrong. By descending a stream of concentrated H2SO4. Yeah, so to absorb SO3 we need to pass descending we need to pass a descending stream of concentrated H2SO4. Or you can frame it like this: for absorption of sulfur trioxide, vapors by descending stream of concentrated H2SO4. Anyways, both of them are the same. After that, so just to recap, we have production of SO2. We have A, blower, B, pyrite burners. Then we have the purification unit for purification of gaseous mixtures of SO2 and O2. We have C, dusting tower. D, we have C, dusting tower. D, cooling pipes. E, scrubbing towers. F, drying tower. G, arsenic purifier, and then H, the testing box. Then we have the catalytic oxidation. We have chamber J, the contact tower, and then we have the absorption of SO3, chamber J. Oh, it's I, sorry. Chamber I for catalytic oxidation. And then finally, we have dilution of oleum. What does dilution of oleum mean? I do not know. So when we do this, when we pass a stream of concentrated H2SO4 and it reacts with SO3, it forms a substance called pyrosulfuric acid, or oleum, and its chemical formula is H2SO4. So then we finally have dilution of oleum, and the final chamber K, called the dilution tank. What we do? We dilute it. We dilute oleum with soft water. And then we have H2SO4. All of this just for an acid. That's pretty crazy. That's pretty crazy. Okay, anyways. Ooh, that was a bad line. There we go. It's a better line. Now let's go little step by step. Let's go little step by step. So, as I told you, the first step, which is the production of SO2. What is that? What did we do? What chamber is it? So the blower sends in the air. That doesn't matter. So step 1 is to produce SO2. So the chamber is the sulfur or pyrite burners one, which is chamber B. Chamber B. Sulfur or pyrite burners. There we go. As a chamber, and now the conversion or the process. Okay, so the conversion, I told you there's two ways. We can either burn sulfur or pyrite burners. Sulfur is much easier because it's just S plus O2 gives us SO2. That's how easy it is. But then there's also the pyrite burners method, which is 4FeS2 plus 11 O2 gives us 2Fe2O3 plus 8 SO2. This gives more, but this is easier. Anyways, so there's two reactions in this, you gotta remember. S plus O2 gives SO2, and 4 FeS2 plus 11 O2 gives us 2Fe2O3 plus 8 SO2. There we have it. Okay then, let's continue. So we have produced sulfur. We have produced sulfur. Sulfur has been produced. Okay, let's go with step 2. What's the second step? It is the contact tower, the catalytic oxidation. Otherwise, it's just purification. Catalytic oxidation. So the chamber is chamber I, or the contact tower. Yeah, great. Chamber I, the contact tower. So we have the conversion. The conversion is from, as I told you, in the catalytic oxidation, we convert SO2 to SO3 by the passage of sulfur dioxide and oxygen through an ion tower packed with catalyst vanadium pentoxide at the temperature 450 degrees Celsius. Initial temperature increases. So what we do is we oxidize SO2. So basically the reaction goes like this. SO2 plus O2 is a reversible reaction with vanadium pentoxide as its catalyst is a reversible reaction with 2SO3. It's not necessarily hard, it's just weird. That's it. At 450 degrees to 500 degrees Celsius, at a pressure 1 to 2 atm. Great. So there's three reactions in the main contact process, which is in the first one to produce sulfur dioxide. So it's in chamber B, or the sulfur air pyrite burners. In that we have sulfur plus oxygen gives us sulfur dioxide, and then 4FeS2 plus 11O2 gives us 2Fe2O3 plus H2SO4. And then we have the catalytic oxidation, chamber I, which is the contact tower. The conversion goes like this: 2SO2 plus O2 is a reversible reaction with vanadium pentoxide as its catalyst under the temperature 450 to 500 degrees Celsius at an atmospheric pressure of 1 to 2 atm, which is a reversible reaction with SO3 plus delta. So it's an exothermic reaction. Whew, quite a mouthful. Yeah. So the catalyst is vanadium pentoxide, or it can also be platinum. It can also be platinum. So let's write that down. Catalyst V2O5 or platinum. Then we have the temperature 450 to 500 degrees Celsius, and then we have the pressure, which is 1 to 2 atm, and the conversion ratio. How much sulfur dioxide is converted to sulfur trioxide? So the conversion ratio, that is 98%. Sulfur dioxide is converted to sulfur trioxide. So yeah, I think after this we'll stop this recording, this part. We'll stop the recording after we finish this page. Okay, then we have step 3, the production of oleum, or the absorption tower. Absorption tower, or the absorption of SO3. Absorption of the sulfur trioxide. So the chamber is a chamber J. Absorption tower. Now the conversion, the actual conversion. So we need to absorb the sulfur trioxide with sulfuric acid by the stream of sulfuric acid, as I told you. So the reaction goes like this: SO3 plus H2SO4 gives us oleum, H2S2O7. And this H2SO4 is 98% pure. Great. Now, this isn't exactly a step, but I think I'll count it as a step. This is the dilution of oleum. So the dilution goes like this: the chamber is chamber K, or the dilution tank. I'm not gonna write that down. So the conversion goes like this. This is the final process in the contact process. Is H2S2O7 plus 2H2O, or not 2H2O, H2O gives us 2H2SO4. Check if it's, yeah, it's balanced. We're fine. Yeah, so this is everything. Again, I'll read out the summary. It's given a perfect summarization of the contact process. So first, the reactants, all the stuff we need: sulfur or iron pyrites, FeS2, in sulfur or pyrite burners. Then we have the catalyst, vanadium pentoxide or platinum. So in the contact tower, yeah, I think it's fine. I think it's pretty simple to understand. We don't need to write that. Yeah, so thanks for watching this part. till this much. This is I'll write down the pages here, how it's supposed to be read. So this is the first page, second, and finally the third. Thanks for watching. Bye.